For that. Goodness gracious. Okay, so what helped me with today's bell ringer? I changed the dates mostly because I didn't have any room. So we're skipping the Wednesday and really doing the Thursday. And I need to increase the screen. If you didn't notice, I had it on the board. Sad. Okay, you just do 5.3 and you should get 5.3v minus something. I don't know what that something is. Okay, and then you distribute the 3, you get 3 plus something. You're not listening. I'm skipping the Wednesday. We're doing the Thursday. I've had this on the board this entire time you've been in the room. I've had the date changed. It makes me sad no one noticed, except Hannah apparently did. Thank you, Hannah. I know. How awesome. 5.3v minus 26.5 equals 3 and 2.98. When you combine those like terms, you get 0.02 plus 10.5v. Now what? Okay, and then I would have 5.3v plus, or 5.3v equals 26.52 plus 10.5v. Now what? If I subtract 10.5v, I would have what? You're on my nerves. You think we can't hear you whispering. We all can. Now what? Okay. I left off the V part because you didn't mean to say that. But okay. Now what? Perfect. And I know that's right, because 5 times 5 is 25, and our number is a little bit bigger than 25, so 5.1 sounds perfect. Just like yesterday, the second bell ringer is a little easier than the first one. For our second bell ringer, I'm going to do it lickety-split. Combine my like terms, I'll have 10w plus 6 equals 7w minus 21. Subtract 6 from both sides. I'll have 10w equals 7w minus 27. Subtract 7w from both sides. 3w equals negative 27. Divide by 3. I get w equals negative 9. Okay, are there any questions about the bell ringers? Then how about the notes? But also get out some colors if you like to be colorful. I have out 5 colors specifically. I'm going to go ahead and draw a coordinate plane. Okay, yesterday we started talking about square root functions. We talked about a specific base form. Does anyone remember the specific base form?
Y equals blank, square root A, yeah.
Now what? Okay. Awesome. Okay, so This was the base form. What was the h and the k? What was that called? Okay, so we discussed yesterday how we could move that vertex, and the h ends up being the opposite sign. I felt like most people had that down. So we're not going to really fuss over that today, although you still have to count. The first point you always do is your vertex. So if you're not comfortable with that, you need to talk to me. Okay, as for the parent function, that's f of x equals just the square root of x. What would the vertex be for that parent function? Yes, which is called the origin. So our vertex is at the origin. That's all, mostly the case for any parent function of any kind of function. Okay, apparently I intend to graph the parent function. Which one do I intend to graph the parent? What number is it? Oh, your numbers are cut off. No wonder. Never mind. Number 1. So we're going to graph 5 things today. The first thing we're going to graph is the parent, which is y equals square root of x. So for the first thing, I'm going to put my vertex at that origin. Okay, how are we counting yesterday? I don't want to make a table of values. Yesterday we discussed how to make a table of values, and that will always work. But today we're going to be smart enough to not even need that. Where would I put my next point? After the origin, where now? Over 1, up 1. Now where? You go over 4 and then up 2. And then next, 5, 6, 7, 8, 9, 1, 2, 3. Okay. Now why are we picking those numbers? The 1, the 4, the 9. They're perfect squares. So if I had room, what's the next number I would pick? 16, because square root is 16. And then after that, 25, because 5 squared is 25, and then 6 squared, which is 36. Okay, so let's say that again for those of us who didn't have it down yesterday. That graph's in blue. I know the square root of 1, it's 1. I know the square root of 4, it's 2. I know the square root of 9, it's 3. That's where these points are coming from. Okay, what is the domain of this graph? How do we do domain and range? Part of our worksheet today is graphing still, but I need to know domain and range. What was domain? So I need to know x values. What x numbers can we use?
0, 1.
And those would be called what kind of numbers? What numbers aren't you saying? You said 0, 1. I see 0, I see 1, I see 2, 3, 4, 5. It's not all real numbers. Because I don't have any numbers over here. What are these numbers? These numbers are negative. I don't see any negative numbers, so it's everything that's positive. So if I'm doing this in interval notation, I'm going to say anything that's bigger than or equal to 0. Because our domain is all positive numbers. What is our range? Our range was driving along the y-axis. What numbers are reaching out to that graph across that y-axis? It is also all positive numbers. We don't start seeing anything except in that first quadrant. We don't have any negative y values or any negative x values, so it's also going to be y greater than or equal to 0. It's still all positive numbers for the y values as well. We're not going to move the vertex today because I'm trying to focus on this counting strategy. But if we were to move the vertex to, let's say, here, wouldn't my domain and range change? They would. If this fake thing was here, I'm just going to draw it real ugly. You don't have to add it if you don't want to. If this was here, what x values could I use? All the way until what number? Yes, so our domain, if this was our graph, our domain would be anything that's bigger than or equal to negative 5. Because if we connect the dots, it goes all the way until negative 5 on that x-axis. What would our range be? Yes, because if we are connecting the dot this way, it goes all the way until negative 2. And if we kept going, of course, it would extend higher. But it goes all the way down until negative 2. So do y greater than or equal to negative 2. Now I say that, then say that's the only one I'm doing like that. I assume you already got that down because we did a lot of it with linear. What I'm focused on is fixing the mess that I made yesterday. What I did yesterday was not wrong. Anytime you don't know what to do, should you plug in points to figure out how to make a graph? Absolutely 100%. Is there tend to be an easier way? Yeah. Okay, so let's graph number 2. I'm going to graph it in brown. Where is the vertex for number 2? It's still going to be at 0, 0. Our vertex is still at the origin because H and K are both still 0. What is the 2? What is it called?
A.
It's A. What is it supposed to change? Like, it changes what looks like the slope. Like, it's not going to look exactly like the parent function. So we used to go over 1 up 1. But what is 1 times 2? So instead of going over 1 up 1, we're going to go over 1 up 2. Because my A is 2, instead of going over 1 up 1, I go over 1 up 2. I used to go over 4 up 2. What's 2 times 2? 4. Instead of going over 4 up 2, I go over 4, and then 2 times 2 is 4. So if I were to go over 9, instead of going up 3, how many would I go up? 6, because 3 times 2 is 6. Okay, are there any questions about number 2? What number would make sense to do? Okay, grief, sinuses. What number would it make sense to do next?
4.
It would make sense to do number 4. Why is that? Because it's another whole number. So instead of going, I should not do that color. I need to use a different color. Instead of going, I'm going to use orange. Instead of going over 1 up 1, I should go over 1 up how many? Yeah, 5. Because 1 times 5 is 5. So 1, 2, 3, 4, 5. Now, if you want to do what we were doing yesterday, and you still just are determined to make you, like, plug stuff in, you're just determined. If you want to plug in 1, you would get 5 times 1, which is 5, so your point would be, lo and behold, 1, 5. If you wanted to plug in the 4, you would get 5 times 2, which is 10. You still would get 4, 10. But man, I'm not having to do near that amount of work, and I'm still getting all the right answers. It used to be over 1 up 1. Now it's over 1 up 5. It used to be over 4 up 2. Now it's 2 times 5, which is 10. So we're going way off the grid. Are there any questions about these? Okay, then we get to the fun ones. Fractions are always so much fun. We know our first point's at that vertex. But instead of going over 1 up 1, what should I do? How much do I go up? A half, because 1 times a half is a half. Instead of going over 4 up 2, what should I do? Just go up 1. Instead of going over 9 up 3, I should go 1.5. We're taking all of our values, our usual values, and dividing them by 2. Connect the dots, Miss Compton, come on. Let's say that again. Instead of doing 4, 2, I did 4, 1. Instead of doing 9, 3, I did 9, 1.5. I'm doing all my normal values in half. But if you are bound and determined to show some work, can you still plug in those perfect squares to prove to yourself that it's 1.5? To prove to yourself that it's 4 and 1, not 4 and 2, and even to prove yourself that it's not 9, 3, but 9, 1.5. You sure can. If you need to do this, you can. But man, that took a few seconds. Just doing it in my brain was so much faster. Okay, so any questions about that? And the last one is the most annoying because of the 1/3. And because my pen doesn't write. Awesome. Love it when things don't work. Need a color. Blue will do. Okay. So I know I started the origin. But instead of going over 1 up 1, I go over 1 up how much? Say it again. It is 1/3, because 1 times a third is 1/3. Instead of going over 4 up 2, I go over 4 up 2/3. Instead of going over 9 up 3, I go over 9 up 1. How are we figuring that out? 1/3 times 1 is 1/3. 1/3 times 2 is 2/3. 1/3 times 3 is 1. But if for kicks and giggles, Julia is just determined to show some work, she still can. What I'm counting and how we're counting this is really all the math behind it. I plug in 1, I get out 1/3, we said 1 1/3. I plug in 4, we used to get out of 2, we say this time we get out 2/3, we'll die because 1/3 times 2 is 2/3. And the same thing would happen if I plugged in the 9, I would get out a 1. So you can show all the work for it if you want to, but you don't have to because it follows a pattern still. Graphs are awesome because they tend to follow patterns. If only everything in life would follow a pattern. Okay, are there any major questions about this? You have your worksheet from yesterday to finish. I need it finished and turned in. And then I'm going to, because my life is behind today, I'm going to copy the one for today. I swear it's only 9 more.